Let's take a minute and talk about type conversions. We've talked about a lot of the different types that are available: characters, ints, shorts, longs, floats, doubles. But if you're going to perform arithmetic operations on those different types, the types have to be the same. You can't multiply a character times an integer or an integer times a float or divide the two or do things like that of separate or differing types. So what happens is something called type conversion. The operands on either side of an operation need to be of the same type for the math to be performed properly. Then the result, as it is assigned into the left side of the equation, the other side of the equals, it needs to be typed properly so that it fits into the resulting area. Generally speaking, smaller types, characters, will be promoted to ints. Ints would be promoted to longs, and so on up the food chain until you get up to doubles. Sign conversions, if you have unsigned values getting promoted or demoted into a signed value, characters to integers, and so on, the sign conversions are handled by the machine's implementation. Some machines use a high order bit for signed, some don't. Our Intel machines do, that we're talking about here. If it's Linux on Intel or Windows on Intel, they use the high order bit to show sign. But different promotions and demotions are sometimes performed by stripping off the high order bits, as many as necessary, to demote a value down into a lesser type. And sometimes high order bits are extended, and whatever is in the high order bit is extended across a number of bytes to promote a value, and that can cause a little bit different outcome than you may want. So it's something to be aware of in your programming. Here's the general rules, and this is straight from K&R. If either operand on either side of the operator is a long double, then the other one will be converted to long double. If either is a simple double without the long extension, then convert the other to double. If either is float, convert the other one to float. Converting then characters and shorts will be promoted to integers if one is an int and the other is not. If either operand is a long, then you need to convert the other to a long to do the math properly. So that's a simple rule of thumb there. And again, you can find that in K&R. Now there's another way that you can do a type conversion, and that's forcing it yourself with a cast. Sometimes that helps you to be able to read the code more clearly, and it certainly helps the compiler because you can expressly say in your code exactly how you want something converted. So here, regardless of what x might be, it could be an integer or a character or who knows what up here in our program, we are going to pass it into the square root function. Well, now square root wants to have a double coming in. And what we are doing here is inside these parens, we use the word double, and that is a cast. That is a type cast. So we are casting x to be a double before it ever goes into the square root. Now x itself is still up here in memory. It is not changed because what we are really doing is passing the value of x, whatever it happens to be at the moment, into this function. And in this case, we're saying that the value of x will be cast to be a double, the appropriate number of bytes and floating point and all of that before it goes into the square root function. Square root is defined in the math.h library to return a double, so that's what will come out of square root, and it will go into y. Now, if y is not a double, the result will be demoted into whatever y happens to be. So if y is a character or something like that, we're going to lose information because we're going to take the square root of x, and it's going to probably not be a whole value. Of course it could be, but if it's not, and it gets stuffed into a small type over here, then we could lose information. We need to be aware of that in type conversions, that it is entirely possible to lose bits off of, in our case, the leftmost end of the byte, and you wind up with a different value than you thought you were going to have. So that's typecast and type conversions, and we'll keep on going with some more C programming.